Hello there, my name is Jason Madigan, and today I'm going to give you a quick demonstration of Quadrant's DNS Policy API. Our DNS Policy API allows you to configure DNS and management for Kubernetes Gateway API listeners and external DNS providers such as AWS, Red 53, and Google Cloud's DNS. It utilizes Gateway API's policy attachment design philosophy. The API features a number of features which will be very useful for users of Gateway API, including DNS management, which can automate the lifecycle of DNS records, policy attachment in terms of a mechanism to actually attach policy to Gateway API resources, support for multiple DNS providers, such as Amazon's Route 53 service and Google Cloud's DNS. There are also optional health checks, which can keep an eye on the hosts that you've got attached to the various DNS records that you've got created and remove any that are no longer reachable. We also have support for a number of DNS-based load balancing features as well, in terms of geo-based DNS load balancing, round robin, weighted DNS as well. To help illustrate our demo today, we've come up with an example usage scenario. So in this particular scenario, I'm a platform engineer and one of my department heads has come to me and brought basically two new requirements to me for one of our biggest services that we've got. Like many companies, we make use of committed spend in some of the cloud providers, and we've been told by this particular department head that we've got about a quarter in order to burn through the remaining budget that we've got on Google Cloud, or else we'll lose the money that we've already committed. And our AWS spend is starting to get a little bit high, so we'd like to reduce that a little bit as well. So also for this particular service that we're talking about, we would also like that specific users in Germany hit a specific cluster for this service for compliance reasons. We've got a very large hybrid cloud multi-cluster Kubernetes platform for all of our services that we've got in our company. We've got clusters in AWS, Google Cloud, and some that are on premises as well, all easily managed with Open Cluster Management. The service that we're going to look at today, it's a truly multi-cluster, multi-cloud application. It's a large, stateful application that runs on a range of different Kubernetes clusters in several cloud providers, and it's also spread across a wide range of geos across the globe. If we can tweak its utilization across these clouds, we should be able to meet our cloud spend budgets, but also be able to bring this particular service into compliance as well. So here's Quadrant and DNS Policy to the rescue. So to do today's demo, we've set up a couple of local client clusters for ourselves. We've got a control plane cluster and two workload clusters as well. In this demo, we're going to make gateways schedulable to all three of these clusters. To do that, we're going to label all three clusters as ingress clusters. For the demo, we're going to create a couple of different open cluster management resources. First things first, we're going to create a managed cluster set with the kind clusters that we've got, and also a managed cluster set binding. We'll also create an OCM placement for our three clusters, and we'll also create a gateway class resource to specify that the Quadrant multi-cluster gateway controller will be responsible for these gateways. Lastly, we'll create our gateway, and we're also going to associate this gateway with the OCM placement that we created earlier as well. One other thing we'll do as well is we'll create a Quadrant TLS policy, but I'm not going to go into a huge amount of detail about this in this demo. Okay, I think we're all done. Let's check our managed clusters. They're all labeled correctly for ingress. So now it's time to schedule a couple of simple Echo services workloads to each of our clusters. So we're going to pick each cluster in turn, and we're going to schedule this very simple Echo app service to each one of them. To check that each of these apps are running, I'm just going to quickly curl each of them, but just bear in mind that right now we actually don't have any DNS records set up, so we can't actually resolve these particular apps from outside yet. So I'm going to pop in a resolve flag here that lets me resolve a certain host to a certain IP address. Okay, all our apps seem to be responding. They're responding with 200 OK. So now let's take a look at the gateways that we've got scheduled to our three clusters. As you can see here, we've got a number of gateways that are up and running and responding to traffic. They are Istio gateways, so we're using Istio as our gateway API provider. Just going to quickly check the status of these, and we can see that gateways have been placed on each of our 3 clusters. As mentioned a little earlier, we don't have any DNS records created yet because we haven't created a DNS policy. So there's no actual way or any easy way for traffic to get to these clusters yet. Okay, to get some traffic to each of the services that are running on these clusters, we're going to set up a new basic DNS policy. This particular example here will give us round-robin DNS for each of the 3 services that are running on each of the 3 clusters. So pretty simple stuff. You'll notice the default weight parameter. We're going to use that basically to set up a default weighting of 120 in the DNS provider here for each of these 3 clusters. Okay, we're going to quickly apply that policy. And we're also just going to give a quick check to see if we've got any DNS records created, and we do. Okay, let's take a look at some of the DNS records now that we've created as a result of applying that DNS policy. Okay, we'll also take a look in Amazon's Route 53 because we're using Amazon Route 53 as our DNS provider here. And we can see that we've got 3 equally weighted records here set up for the 3 clusters that we've sort of introduced into the mix as a result of applying the DNS policy that we just created. Okay, so that looks good. We've introduced a fairly simple DNS policy, and that's able to bring traffic to each of our clusters. But now I'd like to work a little bit on the problem that our department head kind of came to us with, which is basically to ferry more traffic to Google Cloud this particular quarter and less traffic to Amazon. So let's take a look at that right now. Okay, in this more advanced policy, what we're going to do is we're going to apply a custom weighting depending on a particular label or match label that we've applied to our clusters. So in this case, we're going to specify a lower weight for AWS clusters and a bigger weight for GCP clusters. So to do this, I'm just going to quickly override a particular label that we've got here on our managed clusters. And I'm going to label our control plane cluster as an AWS cluster. I'm going to label our workload 1 cluster as an AWS cluster as well. And then finally, I'm going to label our 3rd cluster, which is in Google Cloud. I'm going to label that as GCP. Cool, so our policy has been applied and we've now labeled the clusters. So let's take a quick look at AWS and see what has changed. Cool, so our DNS policy has been applied and it's reconfigured these particular records for us. So now we can see that we've got our new weights applied and more traffic is going to naturally flow to our GCP clusters instead of our 2 AWS clusters that we've got. Okay, with that DNS policy applied, we should see a lot more traffic hitting our GCP clusters as opposed to our AWS ones. That's one of those particular requirements that we mentioned at the start. That's one of those solved. Okay, so for the last challenge that we've been set, we want to make sure that users that are in Germany hit a particular cluster to serve a particular service. So what we're going to do that is we're going to label a couple of our clusters and we're going to label them with a specific geocode. Okay, so for the workload clusters, I'm going to label one of them as being in Germany and I'm going to label the other one as being in the US because that's where most of our users are. And I'm also going to label the hub as being in Spain as well, just for the purposes of this next part of the demo. Okay, this all looks good. You can see all my labels here. So let's take a quick look at a geo-weighted DNS policy as well. So all we need to do here is to add a geo parameter and specify a default geo cluster where we want traffic to go to if no geo has been applied to a particular cluster. So with that done, we can see that we've got 3 different geolocation records set up here, one for Germany, one for Spain, and a default one for the US. So with this particular policy in place, basically if we do a DNS lookup for this particular host or that hosts their service that will hit one of these clusters, it will give you a different record depending on where you are in the world. So if you're in the US or anywhere else other than Germany or Spain, you'll end up on the US cluster. And if you're in Spain, you'll end up talking to the control plane cluster, the gateway that's there. But if you're in Germany, you will end up on the workload 2 cluster. So we're going to take a quick look at a DNS checker tool or propagation tool to make sure that that's all set up okay. Okay, we've done a DNS lookup for the particular host that hosts our app. And we're going to see which clusters that it's going to point traffic at depending on where you are in the world. Okay, we can see that this is all resolving as we would expect. So the majority of traffic is going to end up on GCP in the US, which is what we want. That should keep our department head pretty happy. And also, we've got our compliance sort of stuff pretty much down as well. So traffic that originates in Germany is going to naturally end up on that AWS cluster workload 1 that's based in Germany or labeled in Germany. And also the any traffic that originates in Spain ends up on the AWS cluster, the hub. So all of that should work pretty good, and that should keep our department head really happy. Thanks for taking the time to watch this demo. We hope it was useful for you in terms of understanding DNS policy a little bit more. If you'd like to find out more about the Quadrant project, check out our website or our GitHub page. We're also on Slack as well if you want to chat with us about any of the things that we've demoed here today, or if you're having any issues or you want to just talk to us.